Okay, in this video, we're going to find the area under this curve from t is equal to 1 to 5. So of course, let's get to work. We have to integrate from t1 to t2, and we need the y equation in terms of t, and we also need the derivative of the x equation, and we multiply by dt at the end. So we see we will have the integral from 1 to 5, and the y equation is just 1 over t, so that's very nice. And now, differentiating the x equation, the derivative of square root of something is first we do the 1 over 2 square root of the inside, which is still t squared plus 1. But don't forget the chain rule, the derivative of the inside. The derivative of the inside is 2t, so I will just put down multiply by 2t right here. And don't forget we still have the dt on the very outside. And now check this out. 2 and 2 cancel, t and t cancel, we have to integrate 1 over t squared plus 1. So let me write this down right here for you guys. Integrating from 1 to 5, 1 over square root of t squared plus 1, like this. How can we do this though? U sub unfortunately doesn't work because there's nothing, like this is just a 1. We do notice we have t squared plus 1. So what kind of functions can we use? Tangent, isn't it? Yes, I will show you guys a tangent way to do this right here first, and I'll show you guys a quicker way to do this as well. So let's do it the long way. What we'll do is we'll take this into the theta world. So do tricks up, right? T is equal to, and again, we know tangent square plus 1 will give us secant square. So we will use tangent theta here, and we will just differentiate this so we can get the dt. dt is equal to derivative of this, which is secant square theta d theta. And now we will see this right here is the integral from 1 to 5. And depends on how you like it. You can put in the 1 and 5 in here, or maybe later, up to you. So perhaps I'm going to leave the limits of integration right here for now. In the end, put down the 1 to 5. Because if I put down the 1 and the 5, in the theta world, the 1 and 5 is not nice looking, so I'll leave that later. Anyway, this right here, it's going to be 1 over square root. T is tangent theta. In another word, here we have tangent square theta and then plus 1. And the dt is this, in another word, secant square theta d theta. And now, just like the good old days, you see this right here is secant square theta inside of the square root. Right? So of course this and that cancel, you just have a secant theta. So in another word, we can have this being cancelled with one of this. Therefore, we can integrate secant theta. That's the idea. Let me just put this down. We have to integrate secant theta d theta. And of course, this right here will give us, you have to remember your integrals, natural log of absolute value of secant theta plus tangent theta. And that's pretty much the idea. But let me actually go back to the t world because again, these values are still in terms of t. I don't want to change them in terms of theta because again, they are not nice looking in my opinion. And to go back, just like the good old days, you look at this right here again. We know tangent t is equal to, tangent theta is equal to t. So let me just put this down again, which is t over 1. From here, we can draw a right triangle. T is the opposite side and 1 is adjacent. And the hypotenuse is the square root of this plus that, right? This square plus that square. In other words, t squared plus 1 squared, like this. So with this, we can actually figure out the secant theta and also the tangent theta. And we will end up with ln absolute value. Secant theta is, let's see, secant is this over that, hypotenuse over adjacent. In another word, square root of t squared plus 1. 1 squared is still 1. And we add tangent theta. Tangent theta is of course this over that, which is just t, like this. And usually it will be done, but again, we haven't plugged in the values yet. And I want to do it right here because we can figure this out much better, right? So we will just go ahead and plug in numbers 1 to 5. And it seems that we will have this. Natural log absolute value square root of 5 squared plus 1. And we add 5. And we have to subtract. Subtract natural log absolute value. Plug in 1, we get square root of 1 squared plus 1. And then plus another 1, like all this. So do not put down plus c because, again, this is a definite integral. So you actually have the answer right here already. But we just have to clean up the numbers a little bit. For example, this is natural log absolute value. This is 26 inside. And perhaps we can put down the 5 first. Up to you, seriously, I would keep it the order. Square root 26, and you have to make sure the 5 is on the outside. Likewise, 1 plus 1 is 2, right? So we have minus ln absolute value square root of 2 plus 1. And notice, in fact, you don't need the absolute value because everything inside is positive, right? So you can actually just lose the absolute value and just put down this as parentheses and parentheses. If you really want, you can do this over that, but I think I'll do it. Fine. I will do this over that, which is natural log parentheses square root of 26 plus 5 over square root of 2 plus 1. And this right here will be my final answer for you guys. And I'm not going to rationalize the denominator here. We are all adults now in calculus, so this is okay. And now let me show you guys how else could we have done this right here. Right? So check this out. So another way, this is just another way. Another way, like this. Let's take a look of the integral from 1 to 5 of 1 over square root of t squared plus 1 dt. And I will also remind you guys the following. We will use this fact. The derivative with respect to t. Notice, this right here is actually really similar to the derivative of inverse sine, but the inverse sine is 1 minus t squared. This is the sinh inverse though. So notice the derivative of the inverse hyperbolic sine, in other words, inverse sinh of the input t, like this. This will give us 1 over square root of t squared plus 1. And of course, the order of addition doesn't matter. You can switch it, doesn't matter. So, in other words, you can actually just go from here to here and say this is the inverse sine hyperbolic version and the input being t, like this. And then you, of course, plug in values 1 and 5. And of course, you can put in 5, put in 1, you get the inverse sinh of 5 and the minus inverse sinh of 1. And in my opinion, this is pretty legitimate. But if you want to use the following, you can also do so because you have done your homework. You know what sinh is, isn't it? I will also make a note right here. Sinh, okay, of whatever input. And because we're using t, so let me use t right here. This right here, it's in the natural log form as well. Natural log of the square root of t squared plus 1 and then plus t on the outside. Again, we don't make things up. We have proofs, we have homework questions on this. And yes, this and that are the same. Yes. And in the end, of course, if you plug in 5, plug in 1, of course you end up with this. So I'm going to leave that to you guys. I'll just put down dot dot dot. You end up with this right here as well. Actually, I'll leave that like this ln. No, I'll leave that. Yeah. Square root of 26 plus 5 over square root of 2 plus 1. Right? This minus that. So it's this part will give you that. This part will give you that. Of course, you divide, you still end up with that. So that's it. So remember your integrations.